This particular type of electrochemical cell is called a voltaic cell or a galvanic cell. And that type of a cell, it's repeated here, is a device in which the half reactions are physically separated. The two half reactions are physically separated. And so the half reactions that are separated are spontaneous. And because you have separated them, then the electrons will run through the external wire to get from one reactant to the other reactant. So in that first picture I showed you, the two reactants were mixed together in one beaker. In this case, in order to harvest the movement of electrons, you have to separate the two reactants. So the zinc is the reactant on this side, and in this case, this isn't a copper, this is a silver. Copper, oh, I got the wrong picture. Anyway, that's okay, I just realized that. This is a very similar analogous situation, only this is a zinc copper, this is a zinc silver. There's lots of different types of electrodes you can make. The zinc copper potential difference, which would be read by a voltmeter, is about 1.1 volts. And this one here with the zinc silver is about 1.56 volts. So you can see the potential or the voltage of the cell depends on the reactants. And it really what it is, it's a sum of the push power of the thing that's going to be oxidized and the pull power of the thing that's going to be reduced. And in this case, what's going to happen is the zinc is going to give off its electrons, which are going to travel through the external wire back down onto the piece of silver. The electrons will build up here, and then the silver ion in solution will move towards, because everything's moving around all the time, obviously in a liquid, will move towards that silver electrode and plate out on the silver, okay? And then we've got the salt bridge to carry the ions. Now the reason why you need the salt bridge, here's an example of a salt bridge, here's a drawing of a salt bridge, is because, think about it, if the zinc is giving up electrons and you're getting more and more zinc coming into solution, zinc ion, then the positive charge is going to build up on this side and it's going to limit the push power of the electrons. If you have a lot of positive charge on this side, the electrons are not going to want to be pushed off this, this particular electrode. So what happens is in the salt bridge you might have some what we call inert salt, doesn't really participate in anything, say potassium nitrate or something like that. And what would happen then is as the positive charge of the zinc builds up on this side, the nitrate anions will migrate down this salt bridge into this solution to keep it electrically neutralized and balanced. And on this side, the silver ion is what we call plating out. So this side is losing positive charge. So potassium ions will migrate down into this side to keep it electrically balanced. So this is the basic schematic diagram of a voltaic or galvanic cell. We have separated the two half reactions from the redox reaction into two parts and physically separated so the electrons can move through the cell. And because you've got moving electrons with a voltage, you can get electrical work done.